Okay, this is the exit ticket that you received in your class today that was worth bonus points, or at least one of these. I'm going to go over the different forms. Here I have Form A and here I have Form B. We're going to start with Form A and then we'll talk about Form B in just a minute. The question says, students roll 2 different marbles off of a 0.7 meter high lab table. One large 78.3 gram marble and one small 5.4 gram marble. The marbles both leave the horizontal tabletop with a velocity of 2.5 meters per second, becoming projectiles and landing on the floor below. Assume no air resistance. So this describes a scenario where you basically have 2 marbles and the only difference between them, and they're both going off of a tabletop and they're both going to land on the floor below. Both of them have the same initial velocity whenever they're rolling, and so the only difference is the mass of each. Because this is the same tabletop, it's the same distance from the floor. They're both 0.7 meters high. I know they don't look like that the way I drew it, but just go with me here. And so it says one lab group produces the following graphs showing the horizontal x and vertical y displacement versus time for the larger 78.3 gram marble. So these graphs are for this big marble right here. And these graphs make sense because this shows a constant velocity. This is a position time graph. This shows a constant forward positive velocity. Again, it is a constant velocity and it will be as it moves through the air as well. But it also shows a vertical position that goes to 0 because again it's going to land at the ground, and so vertically it starts out at some height 0.7 meters and it's going to fall, but it's not going to fall at constant speed. That's why I don't have a straight line. This one was constant speed. This one though has acceleration. Vertically it starts out at rest basically because it doesn't have any vertical motion as it rolls off the table, and then once it leaves the tabletop and becomes a projectile, then it's going to increase in its speed vertically at a rate of negative 9.8 meters per second. So again, that's what these graphs are showing. So question A says, how would the horizontal xt graph compare for the smaller 5.4 gram marble? So looking at this graph here, how would this graph compare if I was to draw it instead for this smaller marble? And because the marbles leave with the same velocity, they would have the exact same slope because again the slope of this graph is its velocity, and its mass isn't going to affect its motion as a projectile. Mass has no effect whatsoever on the rate at which it falls to the ground, and so, or on the rate at which it's moving forward. Again, there is no acceleration moving forward, so the graph would actually look exactly the same. So how would it compare? If there are differences, explain how and why. There are no differences here. If they're identical, explain why. They would absolutely be identical. And they would be identical because both marbles have the same horizontal velocity. This is a horizontal launch, and both of them, regardless of their mass, are going to have the same horizontal velocity as they fall. Okay, it doesn't matter if it's this little one or this big one. Okay, and so you would have an identical graph. All right, let's go ahead and look at the rest of the questions. It says, explain how the vertical YT graph compares for the smaller marble. So basically, does the vertical motion depend on the mass? And the answer is still no. Again, all objects, regardless of mass, when we're dealing with things that are projectiles or in free fall, they have the exact same vertical motion. All of them accelerate at negative 9.8 meters per second squared, regardless of their mass. As long as there's no air resistance, which there's not. It told us in the question to assume no air resistance, but again, if we're dealing with projectiles or free fall, we always assume no air resistance unless it tells us otherwise. But if it tells us otherwise, that's not a projectile. That's not in free fall. All right, so again, the graphs again will be identical. And again, it's because the mass has no effect on the rate at which the object falls. And so it's going to fall at the same rate. It's going to start out, we're looking at this graph now, but it's still going to start out at rest vertically because it's on a horizontal surface. It has no vertical motion until it leaves that surface. And then as it falls, its slope is going to get steeper because it's going to speed up. But they're both going to speed up, and they're both going to speed up at the same rate. This rate right here. Okay, so that's what you should have said in B. Question C says, how does the momentum of the smaller 5.4 gram marble compare to the 78.3 gram marble just before impact with the ground? So both of these things are going to hit the ground below. These are my two different scenarios. Okay, same height and everything, but I have my larger one. It's going to have a trajectory like this. I have my smaller one. It's going to have a trajectory like this. Those should be identical. I don't know if I drew them perfect, but whatever. And so we would expect it to hit the ground with the exact same velocity. And that velocity will be at some angle. We could calculate it if we want to, but we don't need to. I know that V final here and V final here are equal. However, that's not what it asks. It asks how the momentum compares. And momentum, as a reminder, is mass times velocity. So if their velocities are the same, but their masses are different, then they're going to have different amounts of momentum. The smaller marble, because it has less mass, will have less momentum. The larger marble, because it has more mass, will have more momentum. But it's not because they have a different velocity, rather it's because they have different masses. They'll hit the ground with the exact same amount of velocity, the exact same place, the exact same time, the exact same angle. Everything's identical except their masses. And because their masses are different, their momenta are as well. All right, let's take a look at form B. It's actually the exact same scenario. It's still a 0.7 meter high lab table. It's still two marbles with different masses. They're still leaving with the same velocity. And we're still looking at graphs, but they're not the same type of graphs. The graphs in form A were position time graphs. The graphs here are velocity time graphs. So this velocity time graph shows a constant velocity, specifically of 2.5 meters per second. This one, on the other hand, shows a velocity that starts out at 0, because vertically, again, you start out with 0 vertical velocity, and this velocity increases at a constant rate. So it's getting faster as it falls, and it's getting more negative as it falls, which again makes sense. The question says, how would the horizontal VXT graph, so it's referring to this one, the horizontal direction being x, compare for the smaller marble? Again, just like on the last one, the velocity is the same. It's 2.5 meters per second, and it's going to be 2.5 meters per second the entire time for both of them, because their mass has no effect on that. It tells us in the question how fast they're moving. So again, these graphs are also identical, because just like in the last problem where we had these marbles that were both moving at the same speed as they fall horizontally, we're still going to have the same horizontal speed as they fall. Again, it's a constant horizontal speed of 2.5. For part B, again, similar question, different graph. How does the vertical graph compare? And it's the same scenario. Both of these have a vertical acceleration of negative 9.8 meters per second squared, because both of them are accelerating vertically due to gravity. And so both of them are going to start out with a velocity of 0, and both of them are going to increase in their speed vertically by negative 9.8 meters per second every second. And so again, the graphs will be identical. In fact, the slope of this graph is negative 9.8. Again, the slope of your VT graph is your acceleration, and my vertical velocity, V sub y, my vertical acceleration is due to gravity. And both of them are going to have that same slope. Mass does not affect the rate at which these things fall because, again, we're neglecting air resistance. Last question says, how does the kinetic energy of the smaller 5.4 gram marble compare to the larger 78.3 gram marble just before impact with the ground? Again, this is a similar question. This is not the same question we answered a second ago. The last one asked about momentum. This one, on the other hand, is asking about kinetic energy. But again, it's the same thing. We have a larger marble here. We have a smaller marble here. They're both going to leave as horizontal projectiles. They're both going to land at some distance away. Again, that range is going to be the same. The air time is going to be the same. The velocity is going to be the same. They're both going to hit at an angle. That's going to be the same. This VF is going to be equal to this VF. They're the same. However, it doesn't ask about the velocity. It asks about the kinetic energy. The equation for kinetic energy is 1/2 mv squared. So just like momentum depended on mass, so does kinetic energy. So even though the velocities are the same, because these have different masses, they will have different amounts of kinetic energy. This one with less mass will have less Ke. This one with more mass will have more Ke. But again, it's not because they have different velocities. Those are identical. Instead, it is because they have different masses.